Week 12, Part 4, Understanding Why Lenses Can Create Images. So we've already talked about refraction at an interface when you have glass. And here I've got a little beam of light coming across here, and I can put a piece of glass into it, and you can see how refraction occurs. I think you can see in there that there's a bending happening right there. So the beam bends as it enters the plastic, and then it bends again when it comes back out. And we've studied that with Snell's law, and we can understand most of that, I think. Now, let's look at what happens when you go through two surfaces that aren't parallel, and look at that. It bends the light off in a new direction. So if you look at it a little bit, you can see that there's a bending toward the normal here. And then as it exits, it bends away from the normal, but those end up both being in the same direction. So the beam of light that's coming out here is off in a new direction. It is bent, whereas before it was traveling in the same direction when it came out again. And it turns out that the amount that it bends, the amount that it is shifted from its original path, depends mainly on this angle up here in the prism. So that's a 45-degree angle. Let's look at some different examples. Here's one that's got a smaller angle, and I think you can see it bends it less. If I switch that in there, that bends it more, and this bends it less. Here, on the other hand, is a 60-degree angle, and that bends it still more. So you can see if you have the two surfaces parallel, so that's like if the surfaces had no angle between them, it doesn't bend it at all. If you have them at a small angle, it bends it a little bit, and if you have them at a large angle, it bends it a lot. And that is what enables a lens to work. Because what's going on in a lens, here is a lens where the two sides are curved. If I put it into the beam like this, that's not so different from the case of a prism. We find bending at both surfaces, and the light ray ends up bending a little bit. But if I move it in toward the middle, you'll see it bends less because the two surfaces are more nearly parallel. And right through the middle, it doesn't bend at all. Here's a kind of a picture to help you understand what's going on here. That it's as if we've got just the parallel case here, and then here's a prism where the two sides have some angle between them, and then up here they have more of an angle. And up at the top, the ray bends a lot, and here it bends less, and here it doesn't bend at all. And on a real lens, of course, it's a nice continuous change from one to the other. Not only that, but it goes through the other direction, and now you can bend things up the other way. Get a nice continuous change back and forth. The other thing you know is that the amount that the ray bends here does not particularly depend on the angle that it enters. What matters is where it enters the lens. So how close is it to the middle? That's what matters, not what angle it enters. I think you can see as I rotate that, it doesn't really change things very much. That is what enables the magic of a lens forming an image. Let's take a look with a different set of rays here. Now I've got 4 parallel rays. And when I put the lens into them, they all come together at a point over here. And because these are parallel rays, that point is a special one, and we call that the focal point. And the distance from the lens to that point is called the focal length of this lens. And different lenses have different focal points. Here's a more extreme lens, thicker. And you can see that it has a shorter focal length. The rays come together closer. It also doesn't work as well. Do you see how the inner rays are focused to a point about right there? The outer rays are focused to a point about right there. So they don't quite work as well as they ought. Here's another kind of a lens. And I should put it in this way. And you'd see that does a pretty good job of focusing the rays together. Even though one side is straight and the other side is curved, this would be a little bit like a plano convex lens. And you can actually turn this around and use it the other way. And it also works, but you do notice again it doesn't work as well. There's a big discrepancy between the place where the two rays focus together. All of this leads to how lenses can form images. Remember, the key fact is that the rays up at the top of the lens are bent down a lot. The rays that go through the bottom of the lens are bent up a lot. The rays in the middle are bent less, and the ones right through the middle wouldn't be bent at all. That is what leads to image formation. And this is the paper that will help to explain that. So if you've got an object here that's emitting light, and it's got a red part and a yellow part and a blue part that are emitting light, the colors of the light are just to help us understand where they go and be able to sort them out a little easier. They aren't significant. It's not as if red rays do something differently than blue rays do in most lenses. So here we just have a bunch of red rays coming from a red part of the object, and they all hit the lens and they bend in different ways as they go through the lens. And remember that the rays that go through the top of the lens bend a lot. The rays that go through the bottom of the lens bend a lot the other way. And the ray that goes right through the middle doesn't bend at all. That has the result that they all come together to a point right here. Similarly, rays from the bottom of the object, from this blue part down here, they bend and all come together to a point here. Now it seems kind of like this part of the lens must be doing something magical. It takes in these different rays from different places and sorts them all out and sends them all to just the right place. But it's not that complicated, because if you look, you can see the red ray coming in is bent a lot, but the blue ray coming in is also bent a lot. The reason they go to different places is that they came in at different angles. They're bent from their original direction by about the same amount. So there's no sorting needing to go on. They're already sorted as they come in. In a similar fashion, the rays that go through the center aren't bent at all, and they're sent on their way just as they came in. Down here, they're all bent up. So all of these rays come together to a point, with the result that an image is formed right in this plane. An image, which means that each point on the object has a corresponding point on the image. All the rays from that part of the object that hit the lens are focused to a point on the image. And all the rays from this other part are focused to their corresponding point on the image. Now, there are various ways you could see that image. One of them would be to put a piece of paper. You could hold a piece of paper up right at that spot, and all of these red rays would form a bright red spot there, and all the blue rays would form a bright blue spot. That's how you get an image on the piece of paper. It also shows you how you need to focus. If you hold the paper at the wrong distance, now the blue rays are hitting a big area, and so are the red rays. So you'll get sort of a fuzzy image. Get far enough away, you won't see anything at all. But as you get close, it becomes a sharper and sharper image until it comes right into focus right there. Go further away and it gets out of focus again.